Hi everyone, thank you so much for coming. So we are at the end of the semester, so I think we have 2 more lectures. We'll continue today in pandas. So we'll talk about data munging or data munging. We started talking about pandas. Pandas basically is like a data frame, creating a data frame, alright? So the data frame, alright? And each column or row, we call it what? A series, alright? A series, alright? So usually each column, for example, to call it a feature, or it has a head, so A, for example, B, C, D, all right? And the data in each column will be usually in the same kind, same type. It could be an integer, it could be float point, it could be object. Object means, in pandas, object means what? String, right? We didn't call it string, we call it object, right? All right? And it could be also nan, right? Okay, nan. Okay, and we said last time nan does not equal to 0. It does not equal. It's not okay. It does not equal 0. It does not equal 0 string. Okay, it's undefined value. All right. And what we tried last week to take a look at. How to fix the data frame, the data, right? So sometimes the data could be, in the head, it should be what? It should be a variable, right? But sometimes it comes as a value. So we have to convert the columns, heads to variables, right? And that's what we call it. What we call this process? What? Melting? Melting. So we call it melting from last week. Melting, right? Okay. Melting, right? Guys, did you go over the material last week? Did you? No? Yes? Okay. The other way is like to move data from the rows from the columns to the rows. What we call it? Pivoting, right? So it could melt, it could pivot, right? It could melt and it could pivot, all right? So last lecture and today's lecture is how to fix the data frame to have the right data before processing, okay? So what you will do if there is a missing data, what you do, right? Right? All right? How you could convert the data. So for example, you could have the data, for example, in here one of the columns like ID, which is 1, 2, 3, 4, right? And it could be defined as integer, right? But does not make sense to be integer, right? It's not integer. You might need to convert it to object. Object in pandas means string. Means string, right? So how can you convert from one type to another type, etc., right? There's many things that. So that's what we call it data munging, and that's what we try to take a look at today. So we'll talk about the data types right? So the data types could be like a standard data types. Okay, what are the standard data types that we know of? Like float, okay, this would be float, right? There's no. This. So, as you know, the data could be float, could be integer, right? It could be object, it could be pool, right? Object which is string, okay? And it could be category. Could be category. So category example for category, for example, the sex, for example, could be male and female. Alright? So it could be different kind of types, okay? Alright, so in here, when you look at this in here, for example, if we have, we're trying to, in here, in the seaborn, we import it as SNS, we call it SNS, alright? And it has the tips, data set. So basically we loaded the tips data set in a data frame, and what we call the data frame, tips. Tips in here is, tips is the data set. Tips is the data set, alright? If we print it, just print tabs dot data types, let's run this. Alright, so the data types we have the total build is in a float 46, the tip is in a float 46, the sex is a category, so it has two values, male and female, and smoker, yes or no, okay, day is a category, time is a category, and the size of the table is integer 64. Alright, so these are the different types that you could have. Alright, if we print the data set, so print tips, which is a data frame, if you take a look at the data set in here, alright, so as you see in here, okay, these are the columns. Okay, 7 columns, and it will have about like 243 rows, right? So it's like 244 rows by 7 columns, and this is a data frame. All right. And then what we did in here after that, okay, print type of tips. Okay, type of tips, like the tips. Just want to make sure it's what? It's a data frame. It's a data frame. After that, in these lines, what we are trying to do is, now we're trying to add a column. So very simple how to add a column in data set. We learned that. So tabs, and we open up a square bracket, and we're going to call the new column, which is sex string. Sex string. All right. The sex itself is a category. It's not a string. So what we do in here, tabs, the sex as type string. So we converted the category to a string. Alright? You understand what we did in here? So the sex is a category. So I want to show you how to convert from category to string. and back from string back to category. And it's very simple. You are given a function called as type. So you converted the sets, or you added a column, and you give it a type which is string. If you take a look, let's take a look at the printout. Take a look at the printout in here. So the section here is a category. After the conversion, when you print the types in here, now the sex is what? Still a category. In here, this sex.
I have added a new column.
Oh, I added a new column. That's right. Okay, so it will be the string in here. In here, what it was converted to, sex the string as an object. We add a new concept object. Right? Then it's still an object. Then I converted it back. Okay, could convert it back as a category. So just to go back in here. Add it as an object. And in here, the total bill also tips total bill, and we changed it to a float. We changed it to float. So basically, what we are trying to say in here that you will be able to convert a column type from one type to another type with a function which is at type. So you could convert it from category to string, from string to category, okay, and you could convert integer to string, and so on and so forth. All right? All right. So the issue here, this will work if all the column elements are existing at the same time. All right, and that's how it should be. But sometimes when you load the data to your data frame, it's not perfect. So you have to make sure, you know, it's the same time. All right. Okay, so this is converting string to string objects. Also, you could convert to so the same thing in here. Okay, what we did, we loaded the data, okay, in the tips, in the tips data frame. All right. When we look at when you print the object in here, okay. So what we have again, total bill is a 464 tips, sets, day, time, and you know the integer. All right. So one thing we trying to do in here is trying to create missing values. All right. So first of all, what we created like a sub data frame, and it has only 10 elements. So from all the elements, we picked 10 elements, the first 10 elements, all right? And then in here, what we did, we went to this line, which is line 1 and 3 and 5 and 7, and we changed the total bill to missing, all right? So when you try to print it in here, okay, this is the original data in here, okay? And in here, what we try to do is to add okay, where am I? So I did not print it after that print, so no, I did actually, it's in here, it should be here, just a second. This is the data set. So I printed the data type, okay, and here the same thing. Then, okay, this will cause an error in here. Tips, okay. And this will cause, then after that, total bill. And what I did exactly here, let me check. Okay, what's done in here. So in here, the sub data frame, total bill, and
Professor?
we use 2 numeric, we change 2 numeric, okay, the total bill, and
Professor?
error ignore. Okay.
You did not run this code. You did
I
not
did
run
not
this.
run it, right? Okay. Here we go. Yes, thank you. Alright. So that's the original data frame, right? Then in here, we added missing values. So in the total bill, as you see here, I added like missing values. Okay, missing values to the data frame, to a subset of the data frame. Okay, for testing, we added like a missing value, right? So after we added the missing values, okay, here, so in here we added the missing values, right? We printed to see the missing values, and if we try to convert, you know, the total bill to float, will give me an error. Why? Because there is a missing value. I'm saying convert the whole column to a float, but there is missing value, so it will give you an error. Alright? Also in here to numeric and total bill, okay, will give you an error. So the way you do it, if you need to convert, you have to add, if there is error, ignore. Okay, and if you ignore it, it will change it for you, but what we'll do is take a look in here. In here. Okay. It changed these to float, but the missing ignored them. It just ignored them. Alright. The other technique you could do, you could say the errors coerced. So if there is missing, what does it do with the missing? Convert it to an AND. Convert it to NAND. So take a look in here. When you use coerce, the missing value will convert it to what? To NAND. Alright? So again, what we did in here, let me repeat what we have done in here. We have a nice data frame. There is no problem with it. Alright? Just for the heck of it, what we did, we went to one of the columns and we added some missing values. Just says missing. Now, with that, I mean, if it's perfect column, we'll try to convert it from to numeric. It's like a string, we need to convert it to numeric. Is there a problem? No problem. Alright? But the problem now, if there is like some missing values, what you gonna do? It will not work. By default, it will not work. So there is two options: to ignore, which will ignore, convert everything else, but these elements that has a missing will not do anything with them. And the other option will do what? Coerce. So when you coerce it, you force it, it will convert the missing to what? To NAND. Simple. Okay? Simple. So that's converted to numeric values. Let's take a look at the categorical data. Categorical data. Alright. So, category like what? Like sex. Two categories, male and female. Right? It's not a float, it's not a string, it's like a category. Anyway. Like the ratings, when you have data for ratings, right? So in the category, you could convert it to object or to string, and so in here, for example, take a look in here. And here you loaded the tips to tips data frame. That's a frame, all right. And if I'm gonna add the sex column from the sex as type string. So what does it do? Changed the sex from category to string. If I type the info, initially the sex is what? Category. When I do it as type, okay, it became an object. Again, object in pandas means string. Means string, alright? So print, convert the sex column into a category data. So in here I convert it back to category. So I could convert it from category to object back to category. There is no problem. Depends on the need that we have. Alright. So what we have learned in here, very simple. In this section, we have learned that the data could be converted in the column, could be converted from one type to type. Pandas have its own types like object, float, boolean, and what else? Integer, right? And could have the category. So there's function given you to convert from one format to another format. All right. After that, we'll talk about very important topics: strings and text data. All right, string and text data, which is mostly that we covered in our Python classes. So how can we create a string? Word, for example, equals whatever. Hello. Right? And we could index it exactly like we index a list. So for example, this would be 0, 1, 2, 3, 4, right? Or this would be how much? -5, right? And this -4, -3, -2. -1, -2, -3, -4, and -5, right? So you could index it with the positive or the negative. So if you say, for example, word 3 print, so it will give you what?
L.
L, right? Okay. If I say instead of 3 minus 1, it will give me O, right? Right. Also, I could use okay. For example, 1, 2, 3 will give you what? EL, 2, right? So this is inclusive, exclusive, right? Also, if I do, for example, like that, 0, okay, 4, 2, you give me
H, L, H, L,
H,
L,
L,
that's it.
so give me the H, the L,
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 that's
or
it.
the O.
No,
No, it's not inclusive, right? It's not inclusive, right? If I need to print, okay, if I need to print the last
Minus
element in the string, what should I do? What?
Minus 1.
1, right? Right? Okay. If I need to print the whole string, what should I do?
Word.
Word. What should I do?
Remove the bracket. Nothing.
Why nothing?
Word. You just print the word. Everything will be printed.
How about if I need to print the last 4 letters?
Last 4. Colon 1.
Huh? What should I do?
One colon.
1 colon.
One colon.
1 colon. Okay. To the end, right? Okay. Or I could say word length of the word. Right? So indexing, right? Okay. So you know, when you have a data frame, okay, data frame which has, and we focus now on the data frame. So this is called ABCD, that has an object. Object which is a string, alright? So sometimes you need to use your talents in manipulating what? Strings. Okay? Subsetting and all of that. There are so many functions that you could use also in a string that you could use, which are ready for you to use. So if you have the book in page 159, you can see, can I bring it? So in here, for example, as you see, right? These are examples for many functions, for some of the functions that you could use. So the top one is to capitalize. So you have a column, you have an object types that you need to capitalize it all. So there's a lot of functions. So it's good to be familiar with all of these. Count the number of occurrences of a string. So you have a string, we need to see how many happens. Okay, how about start with, if you need to see if the string start with the value. Okay, find smallest index of where the string matches, -1 if there is no match. Then for example, another example, for example, lower, copy of the string with all lowercase letters. Upper, convert everything to the uppercase. Replace, so copy of a string with the old values replaced with a new value. So you could copy, right? Split the string into lists. All right. So you have a longer string, and you could save it in a list, right? Partition, center. Z-fill, copy of the string, left with all zeros. So maybe there's examples. So if you take a look quickly in these examples, so let's take a couple of these. So for example, black, night, this is a string, dot upper. So what does it do? Convert it to all upper case, right? Take a look in here. So for example, Ni, split, and the separator is what? Split, a space. So what does it do in here? It will create a list, alright? And how many elements in this list? 1, 2, 3, 4. And that will be a list. So put the elements of the string into the list. So convert it from a string to a list. And the separator is the space. You could determine the space. Take another example. For example, in here, 37 is decimal. Checks off. This is a decimal. Okay, true. Okay, that means there is no letters, and so on and so forth. So there is a long list of functions, right, given to you, or methods given to you that you could handle all the strings inside your data frame. Remember that usually what you do, the data frame comes from where? Collected by people. So mostly like manual entries. Alright? So you'll find many missing values. A lot of missing values. You'll find misentered values. Okay? You'll find wrong values that should not exist there. In the data frame, usually it built of series, right? Columns and rows. All the columns technically should be what? Complete. Should be complete and should be one type. Alright? If you have a missing value, you need to deal with it. If you have none, you have to deal with it. Okay? So before you do anything with the data frame, what you do? Munging. Okay? Remember that you are dealing with a data frame, the size maybe like 1 million by 1 million. Huge data frames. Your eyes and your hands will not be able to help you. Alright? Will not be able to help you. Will not even able to help you to detect. So, before you start doing anything, you might need to go for each column. Okay? And you are determined this, for example, okay? Let's say this column tells you the sex. Okay, so how many values for the sex? Two, supposedly. Maybe there is other, I don't know. Okay, two, right? Two, male and female, right? So the first thing you're gonna go for each column. Let's say that you're doing machine learning or deep learning or whatever. What are you gonna do with this column? You're gonna run a code on it, a test that everything is either male or female. Alright? And if it's not, if there is a values missing, you have to know what to do with it. Alright? If there is like, you know, a value which is completely wrong, instead of male and female written, for example, goat. Okay? There is no gender called goat, for example. Right? So you're gonna deal with it, right? Take for example, like you have a column which all supposedly to be float. Alright? So the wise thing before you start doing anything, and again, you have a million record, you'll not be able to see it with your eye. So what you're gonna do, you're gonna write a testing. You're gonna make sure that all the values in this column is float. If not, deal with it. There's a lot of solutions, right? Alright? Part of your job sometimes to do what? Normalization. Normalization. Okay, I gave you an example last time. For example, the blood. For example, let's take example. The blood sugar, right? I mean, let's say the column is the person has diabetes or does not have a diabetes. All right. Usually when you measure the blood sugar, it's like ranges from 60 to 500. Anything over 120 is diabetic. Less than 120 is not diabetic. Let's assume there is two values, right? And there is something called, by the way, pre-diabetic. Okay? So another range. So let's say there's 3 ranges. So do I care about having all of these numbers? I don't, maybe. Alright? I would like to know if that person is not diabetic or pre-diabetic or diabetic. So how many values I need? 3. Let's say numbers 0, 1 or 2. Or let's say letter N for not, P for pre, D for diabetic. So I'm gonna run certain processing on all the values in that column. And what I do? Normalization. Okay, normalization. Normalize your data, right? Instead of having like range from 60 to 500, I have a range from 0 to 2, for example, or 3 different values. All right? All of this require what? Talent, right? Requiring all of these functions to do, simple functions, right? Like these for your data, right? Okay. So you could have like the split lines. Sometimes you need to split lines, okay? Sometimes you need to do formatting. We learned about formatting, all right? So sometimes you need to join. For example, in here, you would like to join like different values. Join different values. So there is a function given you to join. You have like 4 columns, all right? One for example, longitude. I mean, like the GPS values, and you decided the 4 or 5 columns that give you one address to make it one. So you have to use, like you see in here, the join. You have to use the join. Oops. What is it? The join. You need to use the join function. So for example, D1 in here and D2 in here, and you could join the different values to one value. Sometimes you need to split lines. So there's functions available for you to split lines. So for example, in here, this is a multi-line string, and you know how to create a multi-line string. So sometimes you need to have the talent. This is like a dialogue between 2 people. You need to split it. So you have to know how to use the split lines, and we'll save it for you. And for example, a list. All right. So you could take a look at how it works. Then formatting. Okay, for the output, there's 3 techniques for formatting, right? There is the format function, there is the F function, and there is the C similar language formatting. Okay, so usually as a Python programmer, you pick one that you feel more comfortable to use and just use. Okay, myself, I like to use the format. All right, the most recent one is the F. I'll show you maybe the F. So whatever format you would like to use, so you could use. So for example, in here you have the variable, and then you have the string in here. So it is just a, all right? And when you need to format it, you say string. Where is the string? It is, and it has one variable. And here one variable, and format, and you substitute in this place the variable. And you substitute the variable. What is the variable? /1. So when you say print s dot format var will be substituted in the string. So the output will be it's just a /1. Right? We have learned about using format before early this class. If you forgot, you could use. All right. Then there's also the C print. Anybody program C before? C language? C? Not C++, C. C? Anybody else? C? Okay. So C is, at the C time, myself, the first programming language I learned it was BASIC. Then I learned Fortran. Then I learned Pascal. Then I learned C. Then C++. Then C#, then Python. All right, that's the flow. If you ask me which one the most you loved, anybody can guess? Can you guess? The least, actually, Python.
C#.
Huh? I love Pascal a lot. Pascal. Okay. I know I fall in love with this, but Pascal it's not object-oriented programming. I'm not sure if there is now a version of object-oriented programming. Pascal, it was fun. I mean, Mahdi, I'm sure that you know Pascal very well, because it's the same format for VHDL. You program VHDL, your hardware, right? You do not do VHDL? Prolog?
Hardware.
Huh?
I'm not hardware.
You're not hardware?
Computer science.
Okay. You did VHDL? VHDL programming? So it's the same format like alright. I forgot what I was telling.
You were talking about the C style in the example.
No, C. So C C, it was not an object-oriented programming. It was fun. C still, for people who hardware programmers, they use C. Why C? Why not C++?
Structured programming.
It's light. So you're gonna
Yeah, it's a lot later.
light, right? It's much lighter, right? Lighter. So C is at that time to and C++ when you need to print and read, what do you use? CN and C out. In C we use printf and scanf. Printf, scanf. So still you could use printf of C in here. And by the way, in C++ still you could use that printf. All right. So I mean, you know, you could just it's the same thing. I mean, believe me, you spend like 15 minutes looking out how it works, you'll learn it. There's nothing complex. All right. However, you know, for the speed, for your speed, I mean, you don't have to try the three and mix. I mean, it's good to know three of them, because sometimes what we'll do, you read a code does not belong to you, code from somebody else. So it's good to be able to interpret it, to understand it, but to try to be familiar with one of the text formatting. All right. I like to use format myself. Okay. But the most recent one is the F, which is similar as format, right? It's like in here, for example, okay, the var, the variable is flesh1, and then you start with the F, and then between two, you know, quotes, you put the string. All right? So you could use, just take a look at it, learn. The most important thing is that we have to learn is regular expression. By the way, regular expression is something important to learn in any language. So for example, when I teach Unix programming, I spend the whole lecture teaching the regular expression. Regular expression is the most sophisticated way to manipulate strings. So you could, for example, like string of thousands of lines, write a small code and manipulate it in the easiest, most nice way. The only problem, the syntax is a little bit complex. Okay, the syntax is a little bit complex, that you have to learn how to use it, but you use it in Unix. If you are a systems administrator, you're going to use it a lot. If you are a shell programmer, you're going to use it a lot. If you are having a project related to any with any language, okay, because regular expression is a standard by itself, and the book, I mean, if you're gonna get a book, the book is that size. Regular expression is really, so it's like a whole thing. You could find a job in regular expression. All right, okay, so it's a very good to know the basics of the regular expression. I recommend you to go to this page in here, where you could type regular expressions and give you some advices. So for example, you could ask, I need to do something. So for example, let me give you an example for regular expression. For example, you know, let's say that one of the columns you have is here, for example, a phone number or a social security number, right? So in the phone number, usually what is the format in the United States? 203, okay, 5764113, right? That's one of the formats. Or it could be 203, 5764113. Any other format? Could be +1, 203, 5764113, or you know, different formats. All right. So let's say that you know you have the data, and this, for example, if it's collected by people or entered by people, okay, what is the likelihood to have mistakes or wrong format? 100%. 100%, right? Because everybody writes his phone in a different way, and if you would like to fix it to one format, okay, you have to have a very nice code to handle that or convert it to the right format, right? So the best thing to do it is what? Regular expression. Okay? With a code as much as this, it could convert everything. But you will not be able to understand it, of course. You have to have that. You have to know it, right? Okay, so regular expression, it's the best way to search for a text. So for example, if you need to search for a text, okay, a word, okay, let's say that you want to search for a word, okay, it has to be at the beginning of the line, all right, and it has to be followed by for example, a space, and then 4 digits, digit, okay, and then let's say followed by a space, and then followed, for example, by year. See how complex? You could put your filters, so detailed filters, to look for a certain pattern in your data, okay, so detailed using regular expression. Alright? So it's really very important for people dealing with that. So that's what is regular expression. It's extremely useful. So the extremely powerful regular expression provides a non-trivial way to find match patterns in strings. Alright? Regular expressions in Python use the RE module. By the way, you could use it in Python, in Java, in any language. Okay? I'm sure maybe even Excel has it. You know, maybe there's a module for Excel or everything. Okay, any data scientist has to know how to do it. To use regular expressions, we write a string that contains regular expression pattern and provide a string for the pattern to match. Alright, so let's take a look in here at this rules. Okay, anybody used regular expression before? You did? I'm sure. I mean, everything I asked you did before. Alright, so that's good.
You had us use it in a homework.
Huh?
You had us use it in one of the homeworks earlier.
You want to have homework for it?
No, our previous homework.
Oh,
Earlier in the
was?
semester, you asked us to use it.
Okay. And if you're asking for a homework, I'll give you.
No, we're good.
No.
We're perfectly good.
You just made me happy. You know. So, alright. So, for example, in here, okay. Actually, I have like from my Unix programming, I teach a whole lecture about regular expression. I could send you, if you send me a reminder, I could send you that PowerPoint. It's really nice examples and details there. Alright, so for example, if you need to look at the dot, dot means match any one character. So if you need to match one character, it's the dot. The caret, match from the beginning of the line. So if you need to match a word from the beginning of a line, you have to put the caret. Alright? $, match from the end of the string. From the end of the string. Then the asterisk matches 0 or more repetition of the previous character. So for example, if I need to match, for example, when I say for example asterisk, okay, C. So what are they gonna match? 1C, C, 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 okay, 0 or more, start from 0 or more, C, okay, correct. So if I say, for example, okay, if I say match what does it match? This is for a digit. And this 0 or more. So it will match, for example, 1, 1, 2, 1, 4, 3, 5. Okay, a digit, but it's one digit actually. It's one digit, right? So it's like say, you know, 1. Okay, so 1, 1, 1, 1, 1, 1, 1, 1. Any number of digits, right? So you could really match a very detailed pattern that you want. Okay, very detailed pattern you want. Those people who work, for example, in systems administration, where they take a look at where? Administrators look at where? Check what? If you're an administrator in a Unix system, what do you check quite often?
Logs. Unix system.
Windows system. Huh?
Well, I'm not sure. What do you mean?
log files, right? If you're an administrator, always you're gonna take a look
okay.
at log files.
Yes.
Have you ever looked at a log file?
A makeshift one, yeah.
Okay, so you know how is it? How is it readable? Is it readable? Not at all. Thousands of words in
Mhm.
one line,
Mhm.
if it fits, right? Usually, like data. So it's impossible to grab what you want by your eye. So what usually you have to write a code. And what is the best fit to look for a pattern? Regular expression. Regular expression. So it's a very useful tool. Believe me, there is a whole jobs. I mean, you find like jobs, regular expression programming. Okay, regular expression. Alright. So for example, the plus matches one or more repetition. One or more. The asterisk matches 0 or more. Then the question mark matches 0 or 1. 0 or 1 repetition. M between two curly braces matches M repetition. So if it's 5 repetition. MN minimum and maximum. This is the escape character. A set matches a set of characters. So if I say match square bracket A to Z, then it will match all letters from A to Z. Alright, in here for example the or A or B for example. In here matches the repetition specified. And also, I mean this book does not talk about it. You could save like a pattern in memory, temporary memory, and it could get complex. It could get complex. Alright. In here for example, the \D, it will be for a digit. Capital D, any character, not a digit, is like opposite, right? S, any white space. Capital S, any character, not a white space. Alright, W, word characters for a word, and W, any characters, not a word characters. Alright, so it's like the opposite. Maybe there's a few examples in here. In here you could do like search, match, for match, split, find all, find, and subtract a lot. So in here, first of all, we have to import the packet, RE. Okay, and this is a phone number. Let's say this is the phone number, right? 1, 2, 3, 4. It's like 10 digits. That's the phone number, right? Alright. So if I need to match a phone number, this format is a very simple. So match, I could say match, and I put the pattern, and then I put the string. Okay. So what is the pattern I'm looking for? \D 10 times. So that means how many digits? 10 digits. And then in here the pattern I'm looking for. So it will give me it matched or will not match, true or not. So if I have, this is the pattern and this is the example I'm trying, it will tell me if I say print M, it will tell you matched or not matched. Okay, so if M, print match, if not, it's not matched. Right? Alright, you could get the first string in the string. So, okay, so now let's try to okay, so now we're trying to match a phone number. So how is phone number is written? Take a look in here. Alright, just pay attention to this. So \D, that what? Digit. How many digits I gotta look for? 3. That's the area code. Then after that, what I will have? Space. So \space. How many spaces I could have?
1.
0 or 1. That's why I put a question mark. Okay, I did not put plus. What plus means?
1 or more.
1 or more. I did not put asterisk. What asterisks mean?
0 or more.
0 or more. Could be like 50. Question mark means 0 or 1. So I have a space or not space. Then after that I have digit /D and 3. So we'll have 3 digits. And then a space again, \S question mark. And then what I have? 4 digits. That's a phone number. So basically I'm looking, so I could have a text with 1,000 pages. Alright? And I'm looking for this pattern. So we'll pick up for me all this pattern from this file. All right. So it will, for example, it will match this format. It will match this format, which is 3 digits, space, 3 digits, space, and 4 digits, a 4 number, right? Take a look in here. In here, what I'm matching? I'm matching the other format, which is bracket, 1, 2, 3 digits, close the bracket, space, then 3 digits, then hyphen, then 4 digits. So take a look in here. What do I have? You start with backslash bracket. Why backslash? Because it's scale, right? Then digit, 3 digits, then backslash, close the bracket. Okay, then 1 space, then 3 digits, then a space, then 1 hyphen. You see the hyphen there? Here? You see it? And then 4 digits. Alright? So you could write the patterns, very detailed patterns for what you're looking for. Alright? For what you're looking for. In here, for example, what you added in here, the +1. What is the +1?
Country code.
The country code. So it started, okay, backslash plus, because special code, then space, and plus, then the 1, okay, then space, open parentheses, close parentheses, digits, 3 digits, hyphen, 4 digits, and so on and so forth. So why you are covering regular expression and bandits here?
When you're data munging.
Exactly. So sometimes you need to look for a certain pattern in the data, very detailed patterns, and substitute the pattern. You could substitute, you could replace, you could capitalize, you could marginalize, you could do different things. So if you need to have so sophisticated work, the best thing to do with regular expression. That is the best thing to do. So it's a very handy tool that you're going to use everywhere in a case. So you could do find, for example, find all. If you're looking for a certain pattern, you could substitute. You could do substitution for certain values. All right. Okay. So that's what is regular expression, and you could also do the compile. Okay, create a compile, and so for the compile function is a very simple. So for example, you have a pattern or regular expression dot compile, and you put the pattern inside the P, for example, and here you compile it inside the P. So when you call it P.match and for the string, so P becomes the pattern. You create the pattern, you compile it into a variable, and whenever you need to access it, just P.match or .substitute or .find all and the pattern. Okay, so that will make even the usage for this will be much more simple. Of course, there's 2 libraries, the RE and there's the rigid and the R backward compatible. You could try them apply. Alright? Then we come to the last thing today we're gonna talk about, which is the apply. The apply. Alright. So what is apply? Functions. We learned functions, right? Right, functions. So if I need, for example, there is 2 columns and they have floats, I need to calculate the average. So I could create a function. And apply it to so in here, apply is a short for applying what? A function. You create a function for any job you want, and you apply it in a series. You could apply it on a series. Series means what? Column or row. Or you could apply it on the whole data frame. So you're applying a function that you wrote already. Okay? So it will be like very interesting, and that will automate your work. Automate your work. So So let's take a look in here. So let's create a data frame, our data frame. We have learned that to create a data frame, we have the data frame. This is a dictionary, okay? I have two columns, column A and column B. Each column has how many values? 3. Column A has, anyways, when I print this data frame we just created, okay, this is all like, when I print this data frame, that's the data frame I just created. Okay, 2 columns, A and B, and 3 rows, right? Alright, so now, if I try, for example, in here, I go to data frame and column A and power it to 2. What will happen? It will do what? There's a characteristic of pandas we have learned what we call it. Broadcasting, right? It will broadcast it. So it went to the column A in here, and what does it do? Okay, it will square it, right? Square it, and that's what happened when we printed that, right? Alright, so in here, for example, this is calculating the average, right? So I have X and Y, okay, X and Y, okay, it calculates the average. So what I did in here, okay, whatever, okay, in here apply. So I could do apply. So for example, so data frame in A, okay, apply the function I have written. And the function could be very complex job. So in here what I did, I have a column, right? And then you said apply and square. So what does it do when I print square in here? What does it do? It just squared the first column for me, right? The other function I wrote in here is not only a square in here. Where is it? In here. So how many inputs I have in here?
2.
2. The first one is what I need to the base, and the second one is the value. It could be 2, 3, 4. I could square it, I could cube it, I could do whatever I want. So when I do it in here, it's in here. Okay, A, apply. The first argument will be what? The function. The first argument will be the function, and we'll take the column, and in here what does it take? The exponential, whether 2 or 3. So, and here we'll do 3. So in here, did it for 3, and here, and he did it for the power of 2. Alright? So that's the simplest format of apply. You're writing a function, alright? And you're applying it to, in this case, to what? To a series. You're applying it to a series. Okay, applying it to a series. Okay. And the series happen to be a column. Happen to be a column, right? Let's take this program in here, the same thing in here. What we have the same data frame as you see in here. Alright, there's the data frame. Alright. And now, what is the function I'm trying to apply? Print me, and we're gonna pass a value for it, X, and print X. So when I apply it to the data frame, okay, the first argument in the apply will be the function, okay, and it will apply in axis 0. That means column by column. Column by column. When I'm trying to calculate the average, so an average in here, so column 0, column 1, column 2, to calculate the average for the 3 columns, x plus y plus z divided by 3. So in here, now I'm applying it to a series or data frame, to the whole data frame, right? So taking like apply, and I'm calling the function average 3 columns, applying to them, okay? And when you call it, it will calculate the average, okay? The average of the 3 column, which is like 2, 30, and 40. Okay. In here, it will apply it in the row. This is will apply it in the row. So when we so in here, x row 0 and x row 1, and I'm calculating the average for the row, not for the column. Right? Row for row. So you could apply it in the row, and you could apply it in the column. I mean, the best way to learn it is to do it by yourself. So you have the codes, and you could try it yourself. Okay. So you could use row-wise operations and so in here you have a data frame, as you see in here, a data frame. So data frame typically have at least two. So it has at least 2 dimensions. That's the data frame, at least 2 series, right? So thus, when you apply a function over a data frame, we first need to specify which axis. Okay, axis 0 means column, column. Axis 1 means row by row. Okay, if we want the function to work in column wise, we can pass the axis 0. So for column wise, axis 0. And if you want the function to work in row wise, you have to use the axis 1. So use the axis 0 in here, for example. So in here, data frame you apply and use axis 0. That means column, and you print me. What does it do in here? Print what? The column. So printed the first column in here, okay, and printed the second column. Printed the second column, right? All right, so so the rest of it, give you some examples. You can take a look at them. How to apply different functions, you create different functions that you could apply for the data. Just I think you have to go through it and okay. Last thing is the vectorized functions. Okay, vectorized functions. Alright, so when we apply, we are able to make function work in column by column or row by row. Okay. So so usually you apply in one column. If you need to apply multiple columns, you have to vectorize it. You have to convert it to a vector, and then you apply it on the whole column. So in here, for example, take a look in here. So in here, for example, you have a data frame, create a data frame, okay, from a dictionary. So how many columns we have in here? 2, right? A and B. How many rows we have? 3, right? And that's what we have in here. So when I try to calculate the average for 2x and y, so return, if this is a function, return x plus y over 2. When you apply it to this vector, so average 2, okay, you're passing the first column, the second column, and give you the average, okay? This works because the actual calculations within our function are inherently vectorized. You know, any work in NumPy or pandas, everything will work vector to vector. If you add data frame to data frame, it will work, column by column. It will vectorize. We'll do the broadcast, right? So this is using NumPy, for example. So when you have in here average 2 modified x and 2, but this is the problem. It's not vectorized because we say if it's x equals 20, then return none. Otherwise, calculate the average. So this is, if you run this if you run it directly in a data frame, will give us error. Okay. So before we do that, what we have to do, we have to vectorize it. What is vectorize it? So what we do in B, okay, vectorize the function, and it will give us a different functions that we're gonna use. Then we use the vectorized function in the two values, and it will work. It will work nicely. So, so you have to vectorize the function. Also, lambda, you don't have to write like you know what's lambda, right? Lambda is like a short function. You don't have to write a long function. You could use that. Anyways, so what we have covered today, okay, is data munging. Okay. Again, we have to understand that the data could have the data frame is built of series, vertical and horizontal, columns and rows, and these contain data, right? The ideal data frame, the perfect data frame, it has columns that each column has a certain type and filled. There's no missing values. That does not happen all the time. So you have to do data munging, right? Sometimes you need to have data conversion, type conversion, all right? Sometimes you need to find where is the missing values. Well, you have to do all of that, right? Sometimes you need to have a complex operation for normalizing. So, for normalization. So you are given something called apply. Apply is you could write your own function. It could do a very complex job, all right? And then you apply it to either to a series or to a data frame, right? All right. And that's what you need to learn, how to apply these functions, how to write these functions. All right. I will stop here right now. I don't want to cover too much material today because I noticed that you're not picking up. Guys, did you go over the material last week? Who did not? Okay. You did not? Okay, you don't have it. Okay. So I don't see a point to go further while you are not, and I'm not sure if it's wise that I bundled the homework for you until the end of the semester. So I don't need you to be relaxed, okay? And okay. So the idea, I wanted you to feel comfortable to submit the homework at your own time, but I don't want you also to be very relaxed that you are not going over the material. A couple of students emailed me that they said that they could not go over the material, and they are too busy end of the semester, a lot of projects, and they think the homework is too much. Anyways, I don't care about I don't appreciate this note, but I also don't want burden you with a lot. So so next week we'll go over we'll continue. We'll go over the group by operations split, and then we'll go about data times and all of that, okay? So please make sure that you go over the material. We already covered a lot of material. How is your progress? Let me ask, how is your progress in your homework? Anyone finished any part of the homework? I know you did. Okay.
Almost
No, he
completed.
came to my office. That's
Almost
one.
one.
Huh?
Almost one. One question.
One question, okay. And I mean, there's 4 questions, right? Okay. Anyone else tried it? Okay, you did it? Okay, you did it? Okay, finished one, 2, good. So the rest of you seems like you were in vacation, which is fine. Okay, which is fine. All right, so just try to please try to go, because it's a lot. I mean, to cover it, and you need it for the project. Let me ask about the project. Did anybody take a look at the project?
Yes.
Okay, you did? Okay, you? Okay, so did you start working on it?
We're getting there.
A
Yeah.
little bit, okay. Alright. So seriously, I mean, you have enough homework until the end of the semester. You have a good
Sure.
project to do. Alright. And how about you? Did you
I started writing down what I want to do
the project or
for the
homework?
project.
Project. Alright. So I think the homework will be very useful to do the project. So maybe you need to take a look at the homework. Did we just remind me? The project, is it a group project or individual?
Yes.
Group.
Group of 3.
Group of 3.
All right. So for the project, you know, that it will just, I'm letting you know, maybe you know that already. I say things, I repeat them a lot, I forget. The project will be a demo. Okay, we'll do the last week or week before the last week of the semester. All right, and it will be a thorough demo. So I'll give each group like 30 minutes, 40 minutes to do the demo. And I need to be convinced that you guys did the project, so I might, you know, ask you in the demo to do certain modifications to your project. So definitely if you, simple modifications, right? So definitely, for example, if you have done the project as a group, when I ask you to do simple modification, you know exactly which part handle that. You could go to it right away and change it, you know, in 5 minutes and all. So make sure you work like a team, make sure you do it, make sure that you learn from it, okay? And you do a perfect job. Usually for my evaluation, I mean, I'll try my best to be the presentation in the classroom, okay? So we'll have like a reserve a classroom certain time that all of us come together and we present to each other, all right? The reason for that, because that's how I grade usually, is a relative grading, okay, relative grading. So, you know, I'll try to evaluate the projects best. Maybe we'll have all of them best, all right, which is fine with me, all right, okay. But definitely, usually, definitely, if there is best and better and least, okay, it should be graded differently. So I want you yourself to be in the classroom. I mean, if it's individual work, I will not do that, okay? If it's individual work, I'll do like, you know, person interview for the project, but because it's like a group, all right? So I would like you to compare your work with other groups' work, all right? So what they have done, what you've done, you could ask a question, how you did this and all that. The whole purpose of the whole thing is what? Learning. Okay, I don't care about anything. So if I'm convinced that you have learned and you are able to program well and you will be able to go for a job interview and perform very well, all right? Okay, and you know, become useful for you, I'm happy, all right? I'm happy. And the project will be a crucial thing. So people who did not do well in the exams, they do well in the project, I will consider that. So because, again, that's what tell me that person have, you know, he's doing, you know, and again, a project is not just you give me like a nice demo for something already done. I will ask you to do some modification or changes to your code. So if you are the person done that, or let me put it this way, if you're planning to borrow it from your grandma, okay, all right, just make sure she explains it for you very well, that you are ready for any question. Okay? So tell her, tell your grandmother or grandfather, whatever, okay, that Ma, I mean, thank you for giving me the code, alright? But I need you to explain it to me. You cannot bring your grandma with you though. Okay, so she should not be there in the classroom. So
But
just,
if she doesn't say anything, she just kind of sits there.
huh?
But if she doesn't say anything, she just sits there.
She's welcome. She's welcome, yeah. Or we could go to her house. Okay, if she's too tired to come, okay, we could go there. You know. Alright, so try to use your time wisely. Okay, I tried to give you a room in this semester. I know that we covered a lot of material. I know I asked you like a lot of programming, so I bundled all the homework for you. I'll give you a room that you could schedule yourself and the project. Right? We'll have one more exam. When would you like to have the exam? Would you like to have it in the final week or 1 week before?
Final week.
Final
Final
week.
week.
Final week.
Right. It will be in the final week. It will be in the lab, same format as the first one, but I promise it will be a little bit easier. Okay, it will be, you know, easier, and it will be all about pandas and non-lying. That's it, nothing else. All right. Any questions for me? Nope. Yes.
And for the front end part of the project, is it okay for us to use frameworks such as Book A and D3?
Sure. All right. So again, I cannot. I mean, I see some people late in doing their work. I don't want to, you know, push too much on you. Just try to work in the material we have covered and try to do. By the way, this is a great book. I like this book. Just going through the exercise. What do you think?
Oh, I like
You agree? You like the book?
Yeah.
I did not write it though.
that.
It's not my name here. All right. So, and okay. So it's just going through the exercises, doing them, you learn a lot. And seriously, after that, the homework and the project will be very easy. All right. Have any questions? Email me or stop by my office. I'll be more than happy to work with you. All right, guys. If there is no questions for me, class is dismissed. Thank you.
Thank you.